we'll be calculating pH of various kinds of solution. And to begin with, one of the most simple cases would be when we have a solution of strong acid, just strong acid present in it, or strong base, just the strong base present in it. So say I have a solution of 0.01 molar HCl and I ask what is the pH of this solution. pH is equal to how much? I guess everybody would be able to do it, but we'll do it with process. We'll just write the equation first. So you have HCl. It is a solution with water, so aqueous HCl. I'm not going to write plus H2O, otherwise I have to use hydronium ion on the other side. I'll simply write as H plus aqueous, which we know is actually hydronium and other ions, plus Cl minus aqueous. Now I've used a forward arrow because it's a strong acid and hardly we have a backward reaction going on. It is mostly forward because the Ka value for this acid is very high, as you have seen in the list shared earlier. Now to do it systematically, what we have to write below the reaction is what was initially given. Initially it is said that it is 0.01 molar HCl, and we know that actually we won't have any HCl molecule. All of it will dissociate, and what will happen is you'll have 0 HCl and all of them will get converted to H plus and Cl minus. So this is at the stable condition. So this is what is happening when things have stabilized, or in this particular case of a strong acid, you have actually this in the solution, which is called as 0.01 molar HCl. So what is the pH? pH is simply your negative log of the concentration of H plus aqueous ions, which is minus log of, I write the concentration in 10 powers, so it is 10 power minus 2. So log of 10 power minus 2 is minus 2 itself, and you have a minus outside, so it becomes 2, right? So we very well know that the pH of this solution would be 2, as simple as that. So just quickly do the pH of another strong acid. Say I had asked for 0.01 molar H2SO4. And I'll change the number a bit. I'll tell you the reason later. 0.001 molar of H2SO4. Quickly get to the pH of this. Yes, so I hope you have done, guys. First we'll write the reaction. H2SO4. What would it give if it is having such low molarity? All of it is going to dissociate. And one mole of H2SO4 is going to give you 2 moles of H plus aqueous and 1 sulfate, right? And again, it is mostly forward reaction. I'm saying mostly, and if it is low molarity, full will dissociate, because as a fact, and with respect to the table what we have done earlier, you may recollect that H2SO4 is going to give you first HSO4 minus and H plus. Then this HSO4 may further dissociate to give you sulfate and another H plus. So 2 of the H pluses are not coming together, but if it is dilute, then this reaction is also going to be fully one-sided. I'll repeat, this reaction is fully one-sided because the Ka value for this reaction is very high. So this happens. It's a strong acid because H2SO4 gives you the first H plus very easily, and then HSO4 is there. HSO4 minus is again an acid with a Ka value not as high as the strong acids, but pretty high enough, and you can check in the tables. So with such Ka values, it is going to give you SO4, 2 minus and H plus if it is dilute. So we'll see later with weak acids, if they are really dilute, then what happens? Those weak acids are able to dissociate fully if they are really dilute. Now this guy doesn't have to be really dilute with respect to the Ka value. I'm not wanting to bring in that right now because we'll be doing that in the case of weak acids. So in this question, even if you have overlooked that HSO4 minus will have a different Ka value than H2SO4, which is the strong acid while giving the first hydronium ion. Even if you have overlooked, no problem at all, because this is a dilute concentration given to you, and we can assume that 1 mole of H2SO4 is giving, this 1 mole is actually giving 2 moles of hydronium or H plus aqueous. We can assume that it's not true actually. It is going to give you slightly less than 2. So for this question's sake, we start with 0.001, nothing over there. Then this fully dissociates, we assume, and it becomes 0.002 and 0.001. This is the magic line. This is what is there in the solution. These are the species present in the solution. How much H2SO4? Nothing. There is no H2SO4 present. There is 0.002 almost hydronium ion present, and there is 0.001 sulfate ion present. This is what is in the solution. So what would be the pH? pH is your negative log of this value, which is 2 into 10 power minus 3. Now you'll use your log skills a bit, and if there is a multiplication, you just put it as addition. So it becomes log 2 plus log 10 power minus 3. So, and there is a minus outside. So that 10 power minus 3, okay, I'll write it rather over here for the first time. But later on, you don't have to write so much. You'll do it all in your mind and maybe write the last step to get the answer. Log of 10 power minus 3 will be minus 3, and there's a minus outside, so you'll put 3 over there, and minus log 2. Minus log 2. I hope you know the value of log 2. It's base 10. So it is 0.301, right? So this becomes 2.699. So you can see it is pretty acidic. Values of pH less than 7 is acidic and is coming as acidic. It was a strong acid, so everything is all right. So that is how you find the pH of strong acids. Now if I have to take example of strong base, that too, please do it quickly. Say I take 0.01 molar NaOH. Find the pH of the solution. Since this is your first question of this, I'll just give you a hint. Get the pOH first. Get your pOH and then get your pH. So I hope you guys have done it. Again, we'll start the same way. We'll write the reaction NaOH aqueous. Again, it's a strong base and alkali, so it is going to dissociate fully and it is going to give you Na plus aqueous and OH minus aqueous. That's your reaction. It's an arrow forward only because it's a strong base, and I'm not going to put the equilibrium arrow. There's nothing going to happen backwards, or nothing measurable going to happen backwards. Nothing what we can report, what we have to report is going to happen backwards. Very tiny amount backwards, which is almost negligible. So the initial value given to us, when I say initial in the solution, that's also not true. I'll just say initial value given. This 0.01 moles of NaOH per liter was never there. This NaOH aqueous was never having a molecule. It is always dissociated, but we report the solution as 0.01 molar NaOH because as solid NaOH we would have mixed 0.01 moles of NaOH in 1 liter of water. When that got mixed and we had that 1 liter solution, that solution never had NaOH, because as soon as it mixes, it is going to dissociate fully and going to give you Na plus and OH minus. According to the balance reaction, it should be so much. So what we have is we have POH. Because we have OH in the solution, we'll first get our POH value, which is minus log of the concentration of OH minus, which is minus log of 10 power minus 2, which is a plus 2, right? So POH will be plus 2. Now comes the question of what is your pH. So what should be the pH of this solution? Now we have done earlier that in any aqueous solution at 25 degrees Celsius, what we are going to take is the Kw of water is equal to 10 power minus 14, and this was the multiplication of concentration of H plus aqueous and OH minus aqueous, right? So that's a constant at 25 degrees Celsius. One could say, sir, you never mentioned the temperature. Just assume the temperature to be 25 degrees Celsius if nothing has been mentioned. So out of this calculation, you got this. You know this is a constant, so you'll get your H plus value, right? So from that logic, your H plus value is going to come something like this. I'll just write it over here. The H plus value is going to come as 10 power minus 14 divided by OH minus was 10 power minus 2, right? So it becomes 10 power minus 12. So if I do a pH, then it becomes 12. Now we rather use the fact that your pH plus POH is always equal to 14 at 25 degrees Celsius, right? So once we have got our POH value as 2, this guy is 2, then pH must be 12, right? More than 7. So that way you would have got your pH as 12 and POH you got earlier as 2. So that's the story of strong acid and strong base. Pretty simple.